Okay. It has to do with the lighting, and if it's just the right, I don't know that, oh, I need to tilt it this way. There you go. Okay, so let's turn them on, and remember that we can, how do you turn on, the on key's on the top right. I always try and hit the orange AC key, and it doesn't work, it doesn't turn it on. So we turn it on, so we can clear these, and if you look right above the 9 key, you see where it says CLR in yellow? Okay, so you're gonna hit Shift 9, and then just follow what it says. So it says clear. So yes, 3 for all, equals for yes, and then AC. So second 9, 3 equals AC. But I mean, kind of like the second plus 712, eventually you'll just know what the buttons are, but for now, just follow what it says and it's easy to clear. There's not a lot of settings you can mess up in here like you can in the 83s. That's why sometimes you want to clear out whatever somebody else has done, which makes it wacky. But we can store numbers in here, and so sometimes if, again, things are stored, it's better if it's cleared out before you start so you're not confused about what was there and what wasn't. But the thing I want to look at right now is the fraction button, because that's the one we're going to use some today. And so if you look at right below that, you see the calc button right here at the top. So there's calc, right underneath that is a little fraction thing. Now you can do one of two things. You can hit the fraction button, which let's do that, and then we can type something in. So let's type in 2/3. So we get 2, and then to get to the denominator, you use this big oval button and you arrow down to get to the denominator, and you hit 3. Now if we want to add that to something, you see how your cursor is flashing in the denominator? We need to get it out of the denominator. Yeah, so arrow to the right, it gets it out of the denominator, and then we can add that to 1/2. Now this time when I type in 1/2, I'm going to do it differently. Instead of getting the fraction first and then typing in the fraction, I'm going to type my 1, so basically my numerator. Then when I hit the fraction button, it puts the 1 in the numerator, and then I can do the 2. That's the way I like to do it. It's less keystrokes, and you know, it's like 1 less, but it's not that big a deal. So if I want to add those two things together, it will add those fractions for me, and it gives you the exact answer. But sometimes we actually want the decimal answer as well, but it's going to give you the exact answer anytime it can. So we have to be able to get it to the decimal answer. If you look right above the delete key, you see that SD key? If you hit that key, it will toggle back and forth between the decimal and the exact form. Okay, so that way you can get them both. Okay, does that make sense? It took me a long time to figure this out because I didn't want to read the instructions. I really didn't want to do that. So I was just playing around going, okay, this is great. It's all exact, but I actually want a decimal. And, okay, so we get on that. You need to know how to type in a fraction easily, and then how to get the decimal when you need it. I figure if I show you once, I know that you got it. It's no big deal. All right, so now let's talk about arc length and area of sectors. So on your notes, this is going on page 90 when we're done. All right, so a couple of things. Arc length and sector area you did in geometry. This is a total geometry view, except that it's not going to look anything like what you did in geometry. Because in geometry, we were talking all about degrees. We didn't turn anything into radians. And so the formula itself for arc length and sector area geometrically is kind of ugly because it has a conversion in there. Because basically you have to find it using radians. It's related to radians, but you don't even know what a radian is at that point in geometry. You don't talk about those until afterwards. And so the conversion is kind of built in. So the easier way to do it is just proportionally. But I want you to think about what a radian is and what's happening with this conversion and what the arc length really means. If I go all the way around the circle, okay, what's the length all the way around the circle? What's that called? Okay, circumference is the distance. It is 360 degrees though, you're right. So it is the circumference. It is 360 degrees. How many radians is that? 2 pi. All right, so 2 pi is related to the arc length, right? Who can tell me what the circumference of a circle is? What's the formula? 2 pi r. Very good. So 2 pi r. 2 pi times the radius. So pi here, isn't that we just said that's all the way around the circle? Does that make sense to you? I mean, that is the distance around a unit circle, yes? And so this is this right here, this 2 pi, we're going to write this as 1, we'll put little parentheses around it. This is 1 full rotation in radians. Now remember, all a radian is the ratio of an arc length to the radius. Okay, that's what a radian is. So the radian, which we would call as theta, okay, it's the ratio of the arc length, which we call arc length S here. Not L, because L is used for a whole lot of other things. It's S, it just is, it's a lowercase s. So all a radian is the length of the arc, or the radian measure is the length of the arc divided by the radius, so S over R. And so with a unit circle, your radius is 1, so your radian measure is your arc length measure, okay, instead of like how much it actually opens up to 360. So if this is not 2 pi, okay, we're not going all the way around. So this is 1 full rotation times the radius. Well, if I don't go all the way around, then that 2 pi changes, right? So if we think of 2 pi in radians, all this is right here is the angle measure of how far we go. So if I only went halfway around, isn't that half the circumference? Just be pi times the radius. So it's whatever the angle measure is, but the angle measure is in radians. Or when you did this type of thing in geometry and you did it in degrees, that's when we had to set up a proportion. And when you solved it, basically the conversion from degrees to radians was built into it. You just didn't know that was what was happening. So it's actually a whole lot simpler in radians because we're not having to convert, so it's not nearly as yucky. So your arc length formula is just S equals, make sure you look like that. It looks like an equal sign. S equals R theta. Radius times the angle measure. So if my arc length that I'm looking for is the circumference, it's theta, which is the angle all the way around, which would be 2 pi times the radius, and that's 2 pi r. That's where that comes from. Okay, easy enough? R times theta. But here's the key. Theta is measured in radians. So you got 2 options if it's not. You could do it the way you did it in geometry, which I'm guessing you probably don't really remember exactly what you did. Or we can do it this way and we just convert beforehand, okay, instead of trying to worry about doing it all together. So let's look at how this works. It says, find the length of the intercepted arc given the angle measure in the radius. Give your answer in terms of pi and rounded to the nearest thousandth. Okay, so we have 5 pi over 6. That's our angle measure. And your radius is 3 feet, right? So your formula is S equals R theta. So S is equal to, your radius is 3 times your theta, which is 5 pi over 6. Now let's just talk calculator free for a second, because Miss Archer and I, we kind of went back and forth on, you know, do we give them the calculators, do we not? They have to know how to do it without the calculator. So on this one, we're just going to talk about the easy way to do it without a calculator, and then we can go ahead and type everything in the calculator. We could just multiply straight across and reduce. That's fine. That's not the easiest way. If you're going to multiply anything that's not a fraction times something that is a fraction, I highly suggest you just put it over 1 so you don't do anything weird. And then although I could multiply straight across and reduce, and the numbers are not that bad, I can reduce before I multiply. Okay, this 3 goes into 3 once, it goes into 6 twice, right? So then when I multiply straight across, I really just have 1 times 5 pi, which is 5 pi over 2. And then this is arc length. So what do the units look like on this? It's arc length. Length. I can measure it with a ruler. Feet. And again, on your calculator, if you type in 3 times, let's do this. I want you to see how it's on what happens over here. We'll do 3 times, and then I want it to be 5 pi over, what was it, 5 pi over 6. So if I do 5 pi and then do my fraction, that's one bad thing about doing it the way I like to do it. It's not going to put the whole thing in the fraction, so I'll start with my fraction. Do 5, and then pi is right above the scientific notation thing. So 5 pi over 6. Okay, so you see that right there? And when I hit equals, now here's the one bad thing. You would never, ever, that's like the first bad thing I found about this calculator. You would never, ever, ever, ever write your answer like that. That's bad news right there, okay? Now, it gives you what you need. It's not like you have to go do crazy things. You just have to write it down correctly. Do not write 5 halves times pi. Well, we write exactly what we had, which was 5 pi over 2. You just put that pi up in the numerator, okay? Does that make sense? Always, well, it is possible to have pi in the denominator, but what happens on that calculator, since it has 5 halves times pi, right? So just like I just said, if you ever multiply anything that's not a fraction by something that is, you put it over 1. So when I multiply straight across, I get 5 pi over 2. Does that make sense? Yes, it's possible to have pi in the denominator, but when it's just stuck next to it, basically it belongs in the numerator. Okay, that's a good question. Anything else? All right, so let's look at number 2. We've got S equals r theta. So S equals, our radius is 14.5 times our theta, which is pi fourths. And type that in the calculator, get me the exact answer first. What did y'all get? 29 pi over 8. Do y'all agree with that? Okay. So, oh, we didn't go back and do, I skipped the decimal part of that. That's fine. We don't have to go back. We get 29 pi over 8. I was so worried about what was going on in the calculator. This is in inches. And then we're supposed to do this in decimals as well. Well, all I have to do is hit one button on the calculator, that S&D button. And then you also get that it's equal to 11.388 inches. Everybody okay with all that? Okay, that's pretty simple. Like, you're given the two things, you substitute them in, no biggie. Let's jump to number 5. So this is 15 degrees. Remember, your theta has to be in radians, so we have to convert first. How do I convert degrees to radians? Pi over 180, or is it 180 over pi? I want to go 2 radians. So you put it at the top. So the pi goes on the top. So yeah, pi over 180. Right. You can reduce it by 3, and then so if you do it by hand. Okay, so 3. This gives me 5 and 60, right? And then 1 and 12. And I love that you went to thinking that way first instead of grabbing the calculator. But it's pi 12. The calculator would reduce it for you as well. So, you know, when you're allowed to use it, doing it in your head is great. You know, I mean, that's good, or not in your head, but, you know, doing it by hand. But then also just check yourself. But the more, this stuff isn't going to come naturally to you if you don't practice it. So you need to practice it. Okay. But there's nothing wrong with doing it and then typing it in the calculator to make sure that you really got that answer, because there'll be times where you won't have the calculator in front of you. All right. So is this my final answer? No, that's just theta, right? That's just what I needed. I needed it in that form to be able to work the question. So then that means this gives me S equals the radius, which is 8.4 times pi 12ths. Okay. So what do we get for the exact answer? So we get 7 pi over 10 meters. And then that gives us 2.199 meters. Everybody okay with that? All right. Okay, so on number 6, go ahead and get that in radians first. You know what? You wouldn't even necessarily have to do conversions. It's one you should know, right? So think about it this way. What is pi sixths in degrees? Pi sixths. It's 30 degrees, right? So if this is 11 pi sixths, I almost made it all the way around. Your reference angle then would be 30, or pi sixths, right? So this is 330, and then bam. So it is 11 pi sixths. Which I think somebody said that already. I know I was trying to help everybody else get to that, that thought process, 11 pi 6. Even this one right here. Think about that for a second. If you know that if you know that 30 is pi sixths and 15 is half of 30, then 1/2 times pi sixths is pi 12ths. Okay? So instead of jumping in and having to use 180 every time and reducing all that stuff, think about how it relates to the ones that you know. And again, if you're not sure, then you can always double check yourself with the calculator. But if you notice something like that, see if you can do it without it, and then check yourself. And the more you get comfortable with it, the less you'll feel like you have to check yourself all the time. All right, so then our arc length is r, which is 10.5 times 11 pi over 6. Go ahead and get the exact answer and make sure you're typing them in too. Don't wait for somebody to do it for you. I got 77 pi over 4. Y'all agree with that? Good. Glad we agree. And then that gives me 60.476 millimeters. Any questions about that? All right, so let me throw this out there because this calculator is really nice. When I type in the pi and everything, it all comes out beautiful. It gives me the exact answer. Chances are pretty good if you have, even if you have a calculator, it doesn't even have to be graphing, that does fractions for you that you are using outside of school. It may not like that you do pi. Just like if we were using the 83s and we typed it in like that and we did math enter, which we all love, it is not going to give me that fraction back because it doesn't leave pi like that. So the workaround for that is, you know, it's supposed to have a pi in it, right? Even now, even though I know it's, I don't have to type the pi in. If you just type in 10.5 times 11 sixths, right? Then it's going to give me 77 over 4. And I just know that the pi goes in there. Does that make sense? And then that way, if you have a calculator where it's not going to leave the pi like that, it'll take care of it for you. Okay. All right. So let's look at number 9. The central angle theta in a circle of radius 6 meters has an intercepted 10 meters. Find the measure of theta in radians and in degrees. So here we're looking for the angle. What you should always do, and when you get to, you know, and again, I know not everybody, because especially if you're graduating, you're not going to make it to AP Calculus next year, but we still talk about the AP test, and that's what we're getting you towards. You don't know what they're giving you the points for. Sometimes you get a point for writing the formula down because you have a concept of what's going on. So especially when you're having to work backwards, write the formula down. S is equal to r theta. Because technically, every formula is done the exact same way. You write it down, should be an equation of some sort. You substitute everything you know, you solve for what you don't. So we know the arc length is 10 meters, right? And we know the radius is 6, and we are looking for theta. Okay? Yeah, we divide 10 by 6. So theta is equal to what? 10 over 6, which reduces to 5/3. Yeah, I heard 10 over 6 first. So it reduces to 5/3. So 5/3 is my actual answer. I wouldn't want that in decimal form, because in decimal form that doesn't come out nice. I'd have to round. Like, I can leave that exact, and I do have a concept of that. You throw in pi and whatever else, I might not be able to, you know, estimate it too easily. But I also need this in degrees. So I take this 5/3, and what do I multiply it by? I'm converting, I want degrees, so I put 180 on top. So 180 over pi. We'll multiply that. So it gives me 5/3 times, and in this case I would, well, you could leave the pi out. If you left the pi out and did it, where does pi go when you're done? And, well, this one wouldn't go at the top, right? This would go in the denominator. Does that make sense to you? Because it's in the denominator now when you multiply straight across? Okay. So I'm going to take 10/3, no, not 10/3, that wouldn't make sense. 5/3, and I'm going to multiply that times 180 over pi. And that one doesn't give me an exact answer, right? And it doesn't because it's in the denominator. And you technically don't leave it in the denominator because it's an irrational number, so an exact answer doesn't make a whole lot of sense here. That's why you're not getting it on this one, and it's fine. I mean, this one I wouldn't want a decimal, but here just having the decimal is fine, and we get 95.493 what? What are my units here? Degrees. Yeah. And remember on the radians, it's acceptable to leave the units off most of the time, but writing radians isn't bad either. Okay, are we all good? Any questions at this point? Hmm? Yes, absolutely. Yes, and that's an answer that I would accept from you as well. And what is it you get in the end? You get what, 300 over pi? Yeah. So in the end, you also get 300 over pi. So yes, and that would be a fine answer. Remember when you have a fraction with degrees, you want that in parentheses though, so you know it goes with both and not just the numerator. And that's absolutely okay. If it's not a multiple choice test and it doesn't say, like if this question said, give your answer in exact form. Is my exact form purple or pink? Purple. And so you have to know the difference, that one word. Exact means exact. You had to round here, right? This doesn't have all the pieces to it. So if you don't have, the exact answer is the one that makes you uncomfortable, makes you look like a crazy person at the Home Depot, right? Like I know this is a degree, this is angles, but let's say that I went to I went to Home Depot and I needed them to cut me a board, and I said, okay, I need you to cut me this board. I need it to be 300 divided by pi inches long. They're going to look at me like I'm a crazy person, right? But if I said I need it 95.493 inches long, they'd be like, okay, I can do that. That's on my tape measure, right? So your exact answer is the one that makes you feel uncomfortable, the ones you don't really like. The estimated answer, or the rounded answer, is the one that would require the calculator for you. Okay. Yeah, I know. They might all make you comfortable or uncomfortable. I don't know. These push you out of your comfort zone a little bit, but I think you start to feel a little bit better about them. Okay. Oh, yeah, I agree. I absolutely agree. And I'm all about leaving everything exact, but I like the purple answer better myself. All right, we all good? Okay, good. All right, on the back. Let's look at number 10. Ready? Sit up. Okay, so a merry-go-round rotates 2,808 degrees per ride. Wow. How far would a rider seated 8 feet from the center of the merry-go-round travel during the ride? So this is still arc length, right? Here's your merry-go-round. Here's your merry-go-round, and then here's the center of it. So this person is 8 feet from the center. Oops. Well, this is 8 feet. 8 feet from the center. May or may not be on the much of the outside. I mean, you could have more of the merry-go-round out here, but all I care about is this part of the circle here. And it's going to go around 2,808 degrees. So that's going to make more than one rotation. Would you agree with that? Yes. Okay, it's going to be a lot of rotations. I don't even really care about how many rotations it is. I just need to know how many radians it is, right? So I need to convert this one, and I would think this one, even though, again, I'm all about exact answers, and y'all were fine converting that other one quickly, this one I'm thinking you're probably going to want to use the calculator. So we're going to take 2,808. I want radians, so what do I multiply this by? All right, over 180. So this will give me my theta. So what do you get when you convert? All I want is the radians right now, not the final answer. 78 pi over 5. Okay. Do we all agree with that? Because y'all weren't very quick to respond to that. Okay, so this is my theta. Okay, not my answer, because your answer and your arc length and your radians are both in terms of pi, which I know can get confusing, but remember, all a radian really is an arc length anyway. It's just a different way to talk about it. So we go and we substitute this in. S is equal to r theta. So our radius here is 8. And our theta is 78 pi over 5. Now, before you go type anything in, and I may be too late by saying that, I'm letting you use the calculator, so I don't want you to freak out on me, but you have to remember that there will be times where you have questions like this and you don't get a calculator. It could be on the SAT and it's a non-calculator type question, which may not look exactly like this, or on the AP exam, whatever. You need to know a simpler way to handle it than what most of you do. Okay, and there's more than one way to do this, and so we're not going to talk about all the different ways, but I could multiply straight across and then divide by 5. I think that's probably not a really great idea myself. Because, well, when you do that, it's not going to divide anyway, right? 5 doesn't divide in here and it doesn't in here. So I can't cancel anything. So basically, I'm going to have to multiply that straight across. Yes, you could come over here and you could multiply and you could carry and whatever, but let's think about it this way. Let's round up to 80. What is 8 times 80? That's pretty easy. What's 8 times 8? 640, right? Because 8 times 8 is 64. So 640. We agree with that? And then I take off 16 because I had 2 more than what I wanted. And then when you subtract, because sometimes this simple subtraction is where our brain goes haywire. Take the 640, subtract 10, right? You get 630, and then 630 minus 6 gives you 624, okay? And doing that, oops, then you have to write it correctly, which apparently I can't. There we go. Okay, 624 pi over 5. And if you, every now and then, because I know you're not going to do it on every single problem, do that without a calculator. And then you know what? You have it in front of you. Now check yourself and make sure you're right. I would hate for you to move on and be wrong. But this type of thing, this is where, you know, maybe not so much if it was 16, but like if it said 26, then I'm likely to get 624 out of that. So if you do the 10s first and then the 1s, you're way less likely to have some sort of brain fart. So this is feet, and then I also need this in decimals, so now I actually need my calculator, right? And I have, but I also want you to understand this. I want you to look at what I have in my calculator. Yes, I can put it in the fraction and everything on this calculator, but you may not be able to on another one. If I type this in and you type it in as a fraction, do you think that we're going to get the same answer? Okay, so do y'all type it in as a fraction? You have an answer? Let's see if we agree. Oops, well, we do. Okay, there we go. We agree? And here's why. It's the order of operations. Order of operations says you multiply and divide in the order that you see it, right? So if I have it in fraction form, I'm going to take that 624, multiply by pi, and then divide by 5, right? Even if it's written out like it is right here, the same thing is happening. So I'm just telling you that in case you're using a device where you have to use 1,000 parentheses or, you know, whatever, and you think, oh, I don't know, I think I typed it in the wrong thing. If you think about it, it's going to do the order of operations, and the order of operations would be just the same as if I put this in a fraction. So, all right, so I already forgot. What's the decimal? 071. Y'all agree with that? Because I'm not going to look back at it. Okay, good deal. I'm going to take your word for it. All right, so number 11, Cincinnati, Ohio. Directly north of Atlanta, Georgia. Cincinnati has a latitude of 39.1 degrees north, and Atlanta has a latitude of 33.7 degrees north. If the Earth has a radius of 3,960 miles, how far apart are these two cities? What? Okay. All right. So it says, here's what we know. So we read this, and that happens with a lot of word problems. You read it, and you're like, wow, that was a lot of words. But you have to read through it so you at least have a concept of what's happening. So then we go back. Cincinnati, Ohio is directly north of Atlanta, Georgia. Okay, so here's Cincinnati. Here is Atlanta, Georgia, right? All right, so this whole latitude thing, right? The lines of latitude and longitude, they're actually circles. You agree with that? And so this is somewhere on the Earth. So we've got, you know, let's say that this is the center of the Earth. I know, not drawn to scale. So if I do this, I've got that it's all measured from 0 degrees latitude somewhere, right? So my 0 degrees latitude, let's say that it's like right here. I don't know. That sounds good. This one right here is at 33.7 degrees, and this is at 39.1 degrees, right? I want to know how far apart they are. Well, although if you have a map in front of you, you're going to draw a line, maybe like even with a ruler. But when you measure the distance between two cities, that's actually an arc. Does that make sense to you? Because the Earth is round. So the distance between these two cities is actually this arc right here. So all that is, you see how all that is an arc length? And this is like my 0, so it's just an arc length. But I want this length right here. So in order to find this arc length right here, I need this angle measure. Is that something I can find pretty easily? How do I find that? Subtract, right? I'm just going to take 39.1 minus 33.7. Okay. So do you see how it turns out to be not so bad? But I know some of you, if I'd have just left you alone with this problem, you would have just stared at it and given up before you tried to draw or make sense of anything. So you are capable of making sense of this, I promise. When you subtract these, what do we get? 5.4, right? 5.4 degrees. Okay. All right. So 5.4 degrees, that is my angle. What's wrong with that? It's not my answer. And what do I need to do with it to even get to my answer? Radians. It's another reason why writing your units on there is important, because you know right now you don't have radians because you just put degrees. So I'm going to have to take this 5.4 and multiply it by what? Pi over 180. So when we do that, what do we get for theta? 3 pi over 100. Good. And make sure you're punching these buttons in, punching the buttons to make sure you're getting it, so that you're not just listening to me and waiting on this. Okay. All right. We all okay with that? All right, so now I have theta. So now my arc length is just equal to the radius, which is 3,960 miles times 3 pi over 100. Now, although this is a big number, I just want you to think about this for a second. If you had to reduce this without a calculator, do you see how you could knock these zeros out right here? And then is 5 going to divide in here? No, but I could divide by 2, right? And then I could get it from there. So I'm just saying it's not as bad as you think it is when you see big numbers. Like, sometimes the big numbers are better than smaller numbers that you can do more with. So what do we get for that in the end? And you can do it on the calculator. It's okay. I just want you to see you can do it. Yeah, you do get 198. Yes, if I reduce this is 2 and this is 198. Yes, you're right. And then you're going to do 3 times the 198. What's 3 times 200? What? Say that one more time. Yes. Because I divided, oh, it's 5. Thank you. I'm sorry, I divided by 2 and I wrote the wrong number. Then 3 times 198, 3 times 200 is 600. And then I subtract 6 and I get 594 pi over 5. But if you typed it in on the calculator, it's okay. I just want you to see it's not as scary as you think. This is miles, and we're just going to leave this one as it is because there's not a whole lot more room to write. I'm pretty confident if you type that in the calculator, you can get the decimal out. I mean, I'm just saying. Y'all are capable of that. All right, so let's look at the area of the circle. Area A of a sector, or area of a sector, not area of a circle. What is the area formula of a circle? It's pi r squared. Good. Okay. All right, so this pi r squared, this is actually in radians as well. You know that, like you've been doing radians since 6th grade and you didn't even know it. So the area of a circle is, now one rotation all the way around the circle is 2 pi. So this is the same thing as 2 pi over 2. Would you agree with that? That is pi, right? Times r squared. So 2 pi is one full rotation if I want the entire circle. If I only want part of the circle, I don't want to go all the way around. It's not 2 pi, or maybe it's more. But this right here basically is your theta. It just works for the area of a circle because it's just one full rotation. So if I change that to theta and make this the thing that's divided by 2 here into the 1/2, that's 1/2. Instead of times 2 pi, it's theta r squared. So your area of a sector, that's what this is. 1/2 theta r squared. Comes from the area formula of a circle. Or actually, the area formula of a circle comes from this. Easy enough? And once again, where theta is measured in radians. So here, we have degrees. That's a problem. We take 74 and multiply it by what? Pi over 180. You let the calculator do the work on that. And you get 37 pi over 90. It's not real pretty. So then now that you have this, because this is your theta, you get A equals 1/2 times 37 pi over 90 times r squared, and that's 4 squared. And you can type all that in the calculator at once using the square. Like 4 squared is 16, so if it's easier for you to type in 16, that's fine. But if, 4 and then just hit the square button, type it all in. And get the area of the sector to be what? You agree with that? If you don't, let me know. Like if you're having issues typing things in. So I hear a whole lot of button pushing going on. Makes me wonder if we're having some issues here. So I could do 1/2, 1/2, and then I arrow out of it and I do times. I'm going to do 37 pi divided by 90. Get out of the fraction again, times 4 squared. So you see how that's pretty much exactly what I had written on my paper. Hit equals, and there it is, 148 pi over 45. That's fine, because of the nature for this. And that works on here because it is order of operations, and that's good. If you have addition or subtraction in there, that is not going to work for you. Okay, just know that. So sometimes that works, sometimes it doesn't. All right, let's look at number 14. Well, guess what? That's already in radians. That's good. So this is just a plug and chug problem. Area is equal to 1/2 your theta, which is 2 pi thirds, times 7 squared. Now remember this. You have to at least show that on your paper. You don't get to just have an answer because you know what to type in the calculator. There has to be some proof that you have a process of some sort, okay? And then it should give you 49 pi over 3. And this is kilometers squared because this is area. So again, make sure that you're getting that number, that you're not just... Any questions at all? All right, we're going to do 16, then we're going to be done. It says the area of a sector of a circle with a central angle of 240 degrees is 134 feet squared. Find the radius of the circle. All right, so I need radians first, right? Is 240 an angle that maybe you know? So... 4 pi thirds. Y'all agree with that? Okay, I understand how to think around it? Because 180, this is 60 past 180, right? So 60 is pi thirds. That would be 3 pi thirds. You go one more, you get 4 pi thirds. Very good. Okay, so we got 4 pi thirds. And again, think it, try and figure it out, and then check your unit circle or use your calculator, but try and use your brain before the calculator at all, whenever possible. And I promise you, y'all are already getting better and better at this stuff. All right, so I want to find the radius. So I write down my formula. The area of this sector is equal to 1/2 times theta times r squared. So I substitute in everything I know. I know the 134, that's equal to 1/2 times the theta, which is 4 pi thirds, times r squared. Now, I would not jump straight to the calculator on this one, okay? If these numbers were icky right here and you needed to do that for this, then that's fine at that point. But do we really need a calculator for this? No. 2 goes into 2 once, goes into 4 twice, so that gives me 2 pi thirds. So I'm going to rewrite what I have here. I have 134 equals 2 pi thirds times r squared. Right? So I need to get r squared by itself. What do I do? You what? Isolate. Well, yes, I need to isolate it. How do I do that? I thought you said you estimate it. It's like, no. Good. Multiply by the reciprocal. You could multiply both sides by 3, then divide, but multiplying by the reciprocal is way easier on that. So we're going to multiply by 3 over 2 pi to both sides. Okay. And so then over here, this is going to give me 3 times 134. Oh, 3 over 2 pi times 134 equals r squared. And this is not going to come out real pretty in the end. So it's pi's in the denominator. We could leave it, but we have to take the square root of it anyway. If it's pi in the denominator, it doesn't rationalize nicely, so let's just go ahead and get our answer. We're going to do 3 divided by 2 pi, and then multiply that times 134. Now it's going to give me a decimal, and let's just make a little note here of what to do and what not to do. This gives me 63.98 blah. I'm putting little dots here for a reason. Because you would never, ever, ever write down, that's an R. Never, ever, ever write that down and then type it back in. You can't even read what I just did. I don't know what's going on with my pen here. Okay, because then because you can't round intermittently. So on this calculator, I want to take the square root of that, this number that I don't want to have to type back in, and I don't want to have to do it a weird way, and it's not going to give me an exact answer. So check this out. Type the square root button. You have to have this number in the calculator, but you type the square root button right there. And then the square root is right to the right of the fraction one. Then do the answer key down here by the equal sign. You see that big key that says A and S right here? You hit that key, it's going to take the square root of the last answer. Hit equals, bam, there you go. Okay? So using that answer key can be very helpful when something you needed to round. So you get 7.999. So we get. Do I need to do that again? Yes, you can. And I'm serious. This calculator, in my opinion, I mean, it doesn't graph. This is way better than the 83 or the 84. It's better than the Inspire as well, because the Inspire, there's just too much going on this. This thing is 12 bucks. Okay? And it does calculus. It does stats. You just don't even have those functions on there yet. This thing is amazing. I mean, I get no money from them. I had to pay them. They don't pay me, but I mean, I could be a pretty good spokesperson for them because this is a very good tool at a very, very reasonable price. Okay. Any questions at all? Awesome. So go ahead and glue or tape these in.